Hey 5th grade, it's Mrs. Kyoko with your flipped math lesson for today. Today we're going to be talking about using estimating and compatible numbers to find a quotient, and that there is actually more than one way to estimate a quotient. So here's a problem to get us thinking. Olivia made $159 by selling 75 bracelets. Sweet, nice job, Olivia. About how much do the bracelets cost? So let's find our important information here. It looks like $159 and 75 bracelets. And we want to find out how much do the bracelets cost. So I think my problem is going to be something like 159 divided by 75. Boy, when I look at that, that is a big, hairy problem. So what I can do is use compatible numbers. Instead of using just 159, I'm going to use a compatible number, not necessarily a rounded number, but a compatible number, a number that's close, a number that probably ends in 0, that is easy for me to multiply and divide. So 159 becomes 160, and 75, I can change that to 80. Now, of course, I'm not going to get the exact answer, but I'm going to get an answer that's pretty close. It gives me a good estimate. So that's what we're working on today. We're not finding the exact answers, we're finding really good estimates. So I've changed the numbers to 160 and 80, and now my problem is 160 divided by 80. And that equals what? So that's going to give me about the price of the bracelet. Now this should look awfully familiar. In fact, this was just like the lesson we just did, where we have multiples of 10. 160 is a multiple of 10 because it ends in 0. 80 is a multiple of 10 because it ends in 0. Remember yesterday in our previous lesson we talked about if our numbers end in 0, we can divide it by 10, and that just takes off the zeros at the end, and then it leaves us with our problem, with our base problem. So now we have 16 divided by 8, which equals 2. 2 times 8 equals 16. Right? That's an easy problem. And also 2 times 80 should give us 160. So let's double check. 2 times 80. 2 times 8 is 16, and tack on the 0, we get 160, just like we were doing in the previous lesson. But that's not the only way to solve that problem. There's another way. Or you could use this solution. Instead of changing 159 to 60 and 75 to 80, I'm going to use a different compatible number and see if I get a similar answer. So this time I'm going to take 159 and I'm going to make it 150. That's still pretty close to 159. It's a number that ends in 0. It's a number that's easy for me to multiply and divide. But 75 this time is going to stay 75. And here's why I decided to do that. I thought of it like money. When I have numbers like 25, 50, 75, 100, 125, what does that make you think of? It makes me think of quarters. I think of, a quarter worth 25 cents. Whoops. I almost gave it a dollar sign. Worth 25 cents. So I know I've got 1 quarter, 2 quarters, 3 quarters, 4 quarters, and so on. So if you have a number that ends in one of these multiples of 25, then you can do division that way. So, so what I did is think of it that way. Let me erase a little bit here and get some room. And now I can solve my problem, because I know that 75 plus 75, if I had 75 cents plus 75 cents, that equals $1.50. You know what that means, right? That means that 75 times 2 equals $1.50. 75 cents plus 75 cents is $1.50. 75 cents times 2 is $1.50. And then, of course, that means that if I had $1.50 and I divided it by 75, that's going to equal 2. All right? So that's just another way that I thought of it. It doesn't have to be the way that you think of it. Remember, compatible numbers are numbers that are comfortable for you to add, subtract, multiply, and divide, and that are close to the number. It doesn't have to be an exact estimate. It doesn't have to be rounding. exactly. It's really just close numbers that help you figure out the answer. So let's practice a few together. So do a couple more, and then I'm going to have you do some on your own. So our first one is 287 divided by 42. I see 287, 42. Well, like 42, I'm going to start actually with the smaller numbers. I think that might help me. 42 looks awfully close to 40. 287, even though it's not perfect rounding, that's really close to 280. And these numbers, 28 and 4, are easy for me to divide. So what I'm going to do is I'm going to divide them by 10 first, take off the zeros at the end, take off one of the zeros at the end. If there were more than one, I could only take off one when I divide by 10. And then that leaves me with 28 divided by 4. I know that 4 times 7 is 28, so 7 times 40 should equal 280. Let's check. 40 times 7, 7 times 4 is 28. Tack on that 0 at the end, and I've got 280, just like I started with. All right, let's try another. 320 divided by 11. Well, 320 already ends in a 0, so I'm not going to mess with that one. 11 is really close to 10, right? So this should be pretty easy to divide. Now I see zeros at the end, so if I divide it by 10, take off a 0, then I end up with 32 divided by 1. Well, wait a minute, 32 divided by 1, that's 32, right? So let me double check. If 32 times 10 is going to give me 320. 32 times 10, let's see what that equals. So I've got 32 over here, 1 right there. 32 times 1 is 32. Tack on my 0, 320, and that's what I started with. I'm a genius. Let's move on. 208 divided by 72. 208 and 72. Okay, 72 is pretty close to 70. And 208, well, that would be close to 200, but here's the problem. Dividing 20 by 7 isn't really very easy, so maybe those are not numbers that I want to use. So instead of using 200, I might use 210, which is actually rounding, and that'd be fine. So I've got 21 now divided by 7, and that's a much easier number. So I'm going to take off the ending 0, and that leaves me with 21 divided by 7. Well, that leaves 3. 3 times 7 is 21. So 3 times 70 should equal 210. Let's check. 70 times 3. I've got 3 over here, a 7 right there, and then I'm going to... All right, did you get it? All right, let's move on to the next one. 3,390 divided by 42. Pause it, write it down, solve it. All right, moving on. Number 3, 412 divided by 84. Pause it and solve it. And then the last one, 288 divided by 37. Sorry, that looks weird. It's a 3. 37. Pause it and solve it. All right, let's solve them and see if you got the right answers. Of course, you're doing this after you solved it, right? You're not just skipping ahead. That would be cheating, and you're not a cheater. All right, 1,220 divided by 59. So I'm going to change the smaller number first. I'm going to change 59 to 60. And notice, hey, that starts with a 6. So I'm probably going to be thinking of multiples of 6 here. And it's going to be divided by my other compatible number. I've got 1,220. That looks an awful lot like a 12. And then if I change that to 12 and just kept it there and put zeros on the end, 1,220 is awfully close to 1,200, so that's a pretty good compatible number. So now I see my base problem is 12 divided by 6. So I'm going to take 1 0 off, and now I've got 120 divided by 6. Remember, super easy. 12 divided by 6 is 2. Tack on that extra 0 there, and now I've got 20. So 20 times 6 equals 120. But 20 times 60 should equal 1,200. Let's see if that is true. So let me make some room here. All right, so now I've got 20. I'm going to take it times 60 and see if it equals 1,200. 2 times 6 is 12. Tack on those extra zeros, and I've got 1,200. Did you get it? Did you find 20? That's the answer to our problem. All right, number 2. 3,390 divided by 42. So I'm going to change that 42 first. I'm going to change it to 40. And then, let's see, I've got 4 there, so I'm thinking multiples of 4. And I see I've got 3,390. That's kind of close to 3,400 or 3,400. Because I was looking right here, 33 is awfully close. If I were rounding up to the 100 spot, that would be the bossy neighbor, and that would make it 34, and that would be real rounding, which is not necessarily what I wanted. Or I'm sorry, 34, that's not the one I want. 3,200 would be probably a better choice, because 34 doesn't divide evenly. See, teachers even make mistakes. So I'm not going to do real rounding. I'm just using compatible numbers, and that's fine. So now I've got 32 divided by 40. Remember, I can divide by 10 first, take off that last 0, and then I have 320 divided by 40, and find out what that equals. So I'm going to, oops, not divide by 40, divide by 4. See, teachers really do make mistakes. So 32 divided by 4 is 8. Then I tack on a 0 at the end. I've got 80. So now I have to check and see if 80 times 40 will equal 3,200. So I've got 80 times 40, which is 8 times 4. That's 32.